From the University of Notre Dame, I'm Andy Fuller, and these are Notre Dame stories. The rollout of 5G seemed to be going along smoothly until it wasn't. So why did the airline industry ask for a pause in some areas? And should we expect other disruptions in the future? For answers, we turn to Nick Lanneman, co-director of the Notre Dame Wireless Institute. We're gonna dive right in. We're talking about 5G, and I think most people have been aware of it. Maybe they've seen it on commercials for wireless carriers. But I think if you ask someone to define what 5G is, the vast majority of people, myself included, would probably draw a blank. So maybe let's start there. What is 5G?
Okay, so to me, the term 5G has meaning along roughly 6 dimensions, which is what makes it so complicated. So 5G stands for fifth generation, and specifically fifth generation of mobile cellular technology. And so these 6 dimensions where I think people want to think about 5G are, first of all, it's a set of performance targets that is set by an international organization called the ITU for these cellular networks. In order for us to justify the next generation, it's got to have a certain set of performance targets to try to hit. Mm-hmm. Then there's a set of technology specifications that are established, ironically enough, by the third generation partnership project. And each generation of this technology incorporates many new features. So dynamic scheduling, multiple antenna systems, carrier aggregation, ultra low latency, massive connectivity, etc. So all kinds of different technology features get baked into these standards. But the standards are set in order for these devices to work with each other. So your phone has to be able to work with base stations from multiple vendors and so on. Then 5G is also about radio spectrum, which is the natural resource of the electromagnetic wave propagations that is regulated by governments around the world to prevent harmful interference. And so there's actually multiple bands of spectrum that have been allocated for 5G systems. 5G is also about the products, the chipsets, the phones, the base stations, the network equipment that all these various companies are building and deploying and making sure that they interoperate together. 5G is about the service that the cellular providers market to the end consumers and businesses that use the services. Of course, the biggest carriers in the U.S. are AT&T, T-Mobile, and Verizon. But there are cellular operators all throughout the world that market these services. Mm-hmm. But then finally, 5G is also about a whole new array of applications of mobile cellular networks, beyond just the experience that we're accustomed to with enhanced mobile broadband on our phone. So there's an interest in augmented and virtual reality, fixed wireless access, so potentially replacing fiber and cable services, cable modem services, the Internet of Things, and then also a number of mission-critical applications. And this is probably the biggest change in 5G is mission-critical applications to support the power and electric grid, transportation systems, automotive and railway, and then also public safety and defense. So it's a big deal. There's a lot of different ways to look at it. And so it's no wonder that it seems confusing to people.
Right. So, 2 follow-ups. First one, why update it? Why get into a 5th generation and we assume, generations will continue after this? Is it just about kind of the performance of our cell phones, or is it because technology continues to advance? You mentioned virtual reality, Internet of Things, and so we need better performance from our devices, and we need new bandwidths assigned to them.
It's often a combination of the two. So people will envision new applications and try it out with the existing technologies and find that there are bottlenecks that are preventing that application from becoming reality. So, early on, the notion of browsing the web on a mobile device or even, transmitting video on a mobile device, that was conceived even at the 3G stage. But 3G technology just wasn't providing enough high data rate, reliable communication in order to support that, pretty compelling vision for the sort of reality that we now enjoy on our 4G devices. So each generation, there's new ideas about how to apply the technology. There's new bottlenecks. And in particular, for this jump from 4G to 5G, this notion of reducing the latency or the amount of time that it takes for messages to move around in the network is one of the bottlenecks, particularly for the mission critical piece, for advanced manufacturing, automotive, and so on, safety type applications. The other piece that they hit a bottleneck, broadly speaking, in 4G is in just having many, many devices, not just people, but everything connected to the network. It created a lot of signaling overhead that became a bottleneck to be able to scale up the Internet of Things. So those are two things that people decided to try to address in the 5G standards.
Gotcha. Okay, second follow-up question. You mentioned bands assigned to 5G. Help me unpack that a little bit, because this is kind of a difficult concept, I think, for folks to get their heads around, because it's not tangible in the sense we think of something we can see and say, okay, there's only a limited amount of space here, but the rule of space still applies.
Well, you can think of it like lanes on a highway. For the cellular operator to deploy a network, they need a band of spectrum in which to deploy their network. And generally speaking, they want to have access to that band, and they don't want to have any interference from anyone else in that band. So they want it reserved for their use, and they're willing to pay for that exclusive use to that spectrum. It's called a license to a particular band of spectrum. And so you could think of it as there's a highway, and AT&T can only drive in lane 1, and T-Mobile can drive in lane 2, and Verizon can drive in lane 3. Because of all the demands that these mobile devices are putting on these networks, my smartphone is gobbling up data, it's transmitting and receiving data like crazy. All the carriers have been pushing to get more lanes in the spectrum. Okay?
Gotcha.
And that requires that we figure out as a nation what kinds of bands of frequency can we make available? What other uses of the spectrum have faded with time, and we can repurpose some of these spectrum bands or highway lanes, if you will, for this purpose of better supporting 5G.
5G, again, I think most people saw it or heard about it through a commercial or something like that, but it made headlines recently due to a situation at a number of airports in the country. Can you explain to us what happened there? What was the issue?
So there was concerns that there could be interference from the 5G systems deployed around airports with a radio technology that's built into aircraft that are trying to land. Okay, so it's a very serious safety issue. So specifically, it's a radio technology called a radar altimeter, and it's used to measure the altitude of the aircraft, the distance above the ground or the terrain around the airport, for landings, and especially in low visibility conditions when the pilot can't fly by sight alone. So the radar altimeters operate in a band of frequencies from 4.2 to 4.4 gigahertz. And so one of these highway lanes.
Those lanes, right.
Then most recently, about a year ago, the FCC auctioned off what's called the C-band for 5G, and that license for use of that band was from 3.7 to 3.98 gigahertz. So we're talking about at least 200 megahertz away. Okay, so it's a factor of 10 more bandwidth in terms of guard band than the FM radio band. So there's a fair amount of spacing there. And in fact, the initial deployments were going to be only from 3.7 to 3.8 gigahertz. So there's going to be 400 megahertz of spacing between these systems. The initial pass, the FCC's review, FCC is the spectrum regulator in the US. Their review of all the information submitted to them through the auction process and the proceeding process that they conduct suggested that interference would not be a problem. However, a small set of these radar altimeters are more sensitive to adjacent channel interference than others. And so out of an abundance of caution for safety concerns, the FAA, which regulates the airline industry, started to raise concerns and said, look, we're going to have to manage this more carefully. The rollout of 5G is going to have to be delayed a little bit, constrained a little bit, push the base stations farther away from from the airports than we originally planned to make sure that we keep safety as the top priority. It unfortunately came at sort of the last minute as these cellular networks were due to turn on. But it wasn't the case that 5G was suddenly going to be disrupted or turned off or anything like that. We were trying to add an additional swim lane or highway lane to enable more 5G connectivity and more 5G bandwidth. And so just delaying that, specifically around airports, it's a pain and it's costly for the cellular operators, but I'm sure that over time we'll figure all these things out. And in fact, I heard a number just recently that the FAA has certified something like 90% of the commercial aircraft now to be able to coexist and not be affected by potential interference. I think the right analogy, and I'm just making this analogy up on the fly, it's so let me be clear that the cellular systems have very stringent specifications in the standards themselves on not emitting signals outside of their allocated band of frequencies. However, they are strong signals. And so when you have a very sensitive receiver on this radar altimeter, it can basically be looking too widely. And so it's almost like if I'm driving, if I use my analogy of driving, if I'm busy looking over in another band instead of focusing on my band, I could potentially have an accident.
Yep.
And so that's really the problem, that the radar altimeters were developed, many years ago, and they were developed at a time where the surrounding signals were very low power. Mm-hmm. And so fairly low cost, if any filters were put on to prevent them from looking outside of their allocated band. And so by putting the more high power signal nearby, they've got they're what's called too wide open. And that potentially, there hasn't been any reports of actual interference. This is all just out of concern that there could be interference, and we have to look at this more carefully, again, to try to make sure that we maintain safety.
Mm-hmm. And I imagine it's probably cost prohibitive, or there's other reasons why we can't just fix the altimeters, and instead the choice is to work on the 5G issue, right?
Well, the challenge, of course, is we're talking about two significant industries, aviation and telecom. Who pays for what, right? In principle, the cost of replacing every altimeter is not insurmountable. The question is who pays for it? How long does it take to get that replaced? And it's pretty integrated into the aircraft. So it's not a trivial matter to go rip out an old altimeter and put in a new one.
Right.
But that industry is going to be catching up and addressing to this issue over time.
Do we have concern that the rollout of 5G might affect other industries or services, or right now are we just thinking this is an airline-only thing?
In this particular band, this is the main issue. Okay. The challenge, of course, is that as we try to make other bands available, as 5G and related technologies create more and more demands for radio spectrum, then we have to identify new bands, and then there's going to be new neighboring issues in each of those bands. One band that's being explored, for example, is from 3.1 to 3.45 gigahertz, it's so-called mid-band. It's a lower part of the mid-band spectrum. And there the issue is that a lot of military aircraft have radars that operate. And it's not so much that we have, actual defense exercises going on across the continental United States, but training and testing of those systems require access to the band. And so there's some potential interference concerns there, and we have to figure out how to share that spectrum effectively if we want to keep that. If we want to make that available for 5G, then we have to figure out how to share that spectrum or relocate those devices.
This is, I think, a good jumping off point to talk about your work at the Notre Dame Wireless Institute. This type of issue is kind of what you all deal with on the day-to-day. So explain a little bit about the Wireless Institute and the problems you're looking to solve.
Sure. So we're a research and educational institute housed in the College of Engineering at Notre Dame. And the focus, we were really inspired by one of these neighboring issues from some years ago that had to do with the TV white spaces. So trying to make better use of TV broadcast channels by enabling something like Wi-Fi to coexist in that band. And what was fascinating is that there were certain technology issues at play, but there's also a significant amount of economic and policy aspects to these problems. It's not just about the technology. So we created the Institute to band together a number of faculty who have expertise, primarily technology expertise, but policy awareness And we've been building up the capabilities to do, large-scale research projects on a collaborative basis within the university and also with industry and government to try to address some of these problems and help offer solutions to this broader spectrum ecosystem, as I like to call it.
Mm-hmm. One of those major research projects that you're kicking off right now is something called Spectrum X with the National Science Foundation. Talk to me about that, because that sounds like a pretty watershed project. It's
huge, both for our nation and also for our team here at Notre Dame to be leading the project. So Spectrum X is the latest effort in wireless coming from the National Science Foundation. It's a 5-year, $25 million center award to create a national center for spectrum innovation. It has a significant focus on research, but also, just as importantly, education and workforce development, so that we have more students and workers who are familiar with these issues and can play leading roles in the industry and the government agencies, both the agencies that use the spectrum, but also the agencies that regulate the spectrum here in the U.S. Yeah, so it's very exciting. We have 27 universities on the team. We're building out significant collaborations with industry and government agencies. And we're very fortunate to be leading it from our Wireless Institute here at Notre Dame.
Yeah, I'll ask you to look into your crystal ball. How far are we from 6G, do you think?
Well, so the process is all about kind of concepts and then standardization and then deployment and monetization of the networks. Mm-hmm. So each generation takes about 10 years from start to finish. And we're roughly 4 years into the 5G cycle. So that's why people are really starting to push hard on developing the fundamental research and conceptual notions for 6G right now. And in fact, there's going to be there's a U.S.-led effort to develop a lot of that through an organization called ATIS, A-T-I-S, to really bring a bunch of the stakeholders from the U.S. together, including academia, to conceive of what 6G should be. Mm. And that's launching here very soon. If I had one sort of takeaway message, I would just say that this world of what goes on behind the scenes of your smartphone and your 5G cellular service, this world is really fascinating. There's a lot of really interesting, challenging problems, fantastic opportunities for students to learn and develop their professional careers. And we're trying to make the Wireless Institute and Spectrum X the place for them to do that.
Nick Lanneman, thank you very much.
Thank you.
Notre Dame Stories brings you perspective on the news and tells the stories of Notre Dame's work to be a force for good in the world. It's produced by the Office of Public Affairs and Communications. I'm your host, Andy Fuller. Our music is by Alex Mansour.